Hello, my name is Stacy Stearns, and I'm an Educational Outreach Program Specialist with UConn-Cannar Extension. Today, we're going to talk about GMOs and creating consistent communication messages. I'm here with my colleagues from the University of Connecticut, Cindy Tian and Bonnie Burr, who will introduce themselves in just a minute. We're going to talk about a topic that people only have an emotional reaction to. You either love them or you hate them. So let's talk about GMOs. This is a topic that when you talk about it, people will already feel like they know more than you and will have some opinion. We're going to help you to communicate with these people. This presentation provides an overview of an online course and certificate that we're building, and we'll share tools with you on creating consistent communication messages. Our funding sources include the UConn David and Nancy Bull Cooperative Extension System Grant for Innovative Programming, Northeast Ag Enhancement from Farm Credit East, and UConn-Cannar Extension. As I mentioned, my name is Stacy Stearns, and I am an Educational Outreach Program Specialist with UConn Extension. I have a master's in Agricultural Education and Communication. And my personal conflict is that our family owns a dairy farm where we produce and process our own milk and deliver it to wholesale and home delivery customers, and we label our milk as non-GMO. Now my colleague Bonnie.
Hi, my name is Bonnie Burr, and I am the department head for the Department of Extension at our College of Agriculture, Health, and Natural Resources at UConn. I have no conflict of interest that I have never received funding. However, I do want to acknowledge that I have served on the Connecticut Farm Bureau Policy Development Committee, and we do have policy supporting GMO at Farm Bureau.
Cindy?
Hello, my name is Cindy Tian. I am a professor of biotechnology in the Department of Animal Science at the University of Connecticut. My prior education is that I have a master's and PhD from Cornell University, and I have started working in animal biotechnology research since 1998. So over the years, I feel like I have learned a thing or two about genetic engineering, and I would be very happy to share with you what I have learned over the years of working on genetic engineering. So I feel like I am hopefully I am the right person for you to rely on. It's like, you know, when you have a toothache, you don't call a plumber, you don't even call your cardiologist, right? You call your dentist. So hopefully I am the person that would fill in the gap, the need for information on biotechnology research. And my conflict of interest, I do not have any research funding or any funding from the biotech industry. All my research funding are from the USDA and the NIH.
Okay. Accepting or rejecting GMOs is an individual decision. However, all decisions that consumers make should be based on facts. An overwhelming majority of science believe that GMOs are safe, according to the National Academies of Science, Engineering, and Medicine. Information from science-based sources can be hard to find in the flood of information that's available on the internet. With that in mind, experts in agriculture, health, and natural resources at the University of Connecticut, or UConn, are providing science-based information to help consumers make their own decisions about GMOs. One of the target audiences we started with was our farmer audiences that Extension already works with, and helping them to learn to communicate with their consumers about GMOs. Misaligned messages from farmers, food labels, and friends further confuse consumers. Suspicion surrounding technology continues to grow. So therefore, our team decided to make several initiatives to help address these issues. The first was that we created a website, The Science of GMOs, that you can see in the top center of your screen. This is based on a similar project that Purdue Extension had created. Next, we advertised our website, which you see in the bottom center of your screen, on several different platforms. So this is one of the advertisements that we included. We surveyed our audiences before we created the website and all of these educational outreach materials, And the results of our survey have driven our communication campaigns. We had one survey for consumers and another survey for farmers. And on the left side of the screen, you see a fact card that we made. This is the front side. It's a two-sided fact card. This was provided to farmers to share with their audiences. We also did social media campaigns, and we've created videos and other materials. So the online certificate that we are developing builds off of the previous materials and helps our farmer audiences, extension educators, and consumers communicate about GMOs. Do you know someone with diabetes? While most people associate GMOs with food products, their use began in the medical field with insulin. The Food and Drug Administration, or FDA, approved insulin for use in October of 1982, after rigorous testing, clinical trials, and review. Prior to that, diabetics used insulin obtained from the pancreas of cattle or swine. Supplies were dwindling, and there was fear that the insulin shortage would result in negative health ramifications for patients. The recombinant DNA technology that is used in insulin, that we now refer to as GMOs, provided a safe and effective alternative. In fact, GMO insulin is a closer match to human insulin, and patients who could not tolerate the previous versions are able to use the insulin today without any negative health ramifications. Despite the health benefits of GMOs, 80% of consumers and respondents to a 2018 Food and Health Industry Survey report from the International Food Information Council Foundation are confused about food or doubt their choices because of conflicting information. The report found that context of GMOs influence consumer perception and opinion. The Pew Research Center found that 49% of Americans think genetically modified foods are worse for one's health. In short, many people fear or may be suspicious of GMOs, but there is a long and important history that most people would applaud. Insulin is such a case. And now Cindy's going to talk about the definition of GMOs.
Thank you, Stacy, for the background information. I would like to give the definition of GMO, and I'm going to talk very briefly why we're making GMO and also whether they're safe. There is a lot to talk about. I can spend hours just talking about these different topics, but today is just a teaser, basically, and I would be very happy to provide more information, so feel free to contact me by phone, email, or any other social media. So before I get into the definition of GMO, I wanted to bring everyone on the same page in terms of a few terms that we use that I'm going to use in this talk. So first of all, we know that DNA is the molecule of genetics, right? And in the DNA, we have things like called genes, right? The gene is actually just a fragment of that DNA that does something. So basically, it either encodes a protein that we use, like our muscles, or a gene can regulate other genes, right? How much of that DNA has a function? Well, in our genome, it's only about 1% of our DNA does something, it's a gene, right? So there's also another term that I will use, it's called the genome. The genome is actually all the DNA, all the genes in one species added together. So you can say the human genomes, and that is the genome, all the DNAs in humans, right, in a cell. So most of the times our DNA in our cells would stay in this kind of uncoiled form. You can see that this is strands of DNA. It's a total mess, right? So they're very fragile, they're very thin, they break off, they get repaired, and things that get inserted and deleted, it happens all the time, right? And only for a very short fraction of time when our cells are dividing, our DNA would condense and form these things called chromosomes. But the majority of the time, our cells have this kind of mess balls all over the place. So basically, if people say that we have a pristine genome, that does not happen, right? Nobody, not a single organism has a pristine genome. Okay, so now let's go back to the GMO definition. We all know that GMO stands for genetically modified organism, right? Now, does that mean really anything? In fact, it's actually a misnomer. Why? Let's take a look at the corn, for example. So this is the corn that we have today, right? It's beautiful multi-kernel rows. But if you look at the corn that we used, that were first introduced for food purposes, it's this little thing that has just one row of corn kernels, right? And over the years, from this to something happened by breeding, right? And these are the things, the different varieties that we have today. If you grow these, you're gonna get these. You don't get that, right? So definitely there is genetic modification, right? So just this genetically modified organism, when you talk about genetically modified organism, you're not talking about this, right? So people have tried to use another definition. They say that the GMO is an organism with a foreign gene inserted, right? Because when you do this kind of breeding, you breed corn with another type of corn, right? So everything happens within the species. So what if an organism has a gene from another species, and that's a GMO, right? So let's look at that definition. And if you just look at the human genome, right? We have 3 billion base pairs in every cell, right? That's our genome. And in that genome, we have 10,000 copies of viral sequences. So viruses accumulate, attack our genome, accumulate in our genome, inserted in our genome. And that's about 8%, right, of our genome. So basically, we are more genome than our humans. Why? Because there is another 40% repetitive sequences that were derived from viruses. So basically, these are also 48% of our genome is actually viral sequences. So we are definitely, if you use the definition that we just gave, a GMO is an organism that contains a foreign gene in the genome. We are definitely walking GMOs, right? So which is actually the case. In addition to viral sequences, in our genome, we have bacterial sequences, sequences from other microorganisms. We also have plant genes in our genome, right? This was published in 2013. This group of scientists sequenced the genome. You can see that these are the different species they studied, the primates, includes humans, and these are the species genes that we primates contain. You can see that 5.4% of our genome is actually plant genes, right? So we are definitely GMOs using that definition. And you may say, well, that's not what we're talking about. So how do we differentiate natural GMOs like humans and corn, right, to the ones that people generate? So we give a final definition that we hope is consistent across the entire field, is that the GMO is an organism that has genetic changes artificially made using recombinant technology. So basically, you have to first artificially make genetic changes, right? So these are genetic changes made purposely by breeding. It is purposely made, but they did not use DNA technology. Therefore, these are not GMOs, right? Humans, we have also genetic changes, but they are also not made by DNA technology. So therefore, we don't fit into that definition. So the ones that we talk about, GMOs, they fit into two things. Number one, the genetic changes are made artificially. Number two, the genetic changes are brought about by DNA technology. So basically, there are other definitions which are much better than the word GMO. Genetic engineering is one of them, or the USDA would like us to use a new term called bioengineered organism, right? So that basically replaces GMO, because GMO really is a misnomer. It does not differentiate all of those things that we just talked about. And this is the symbol that the USDA would like us to use to describe genetically modified, purposely made organism by DNA technology. And in this talk, I am still going to use the word GMO because, it's simple and everybody uses that, and it's, people are familiar with it instead of using bioengineered. So when people think about GMO, they think about plants, but in fact, there are lots of GMO animals. And you don't hear a lot about them. You don't hear a lot of pushback about them because they save lives, right? The GMO animals are made to create drugs to treat human diseases, like the example that Stacy just gave, insulin, right? It's appreciated that people make these GMO drugs for human diseases, right? Imagine there is no GMO insulin. This world will collapse, right? Because a high percentage of people have diabetes. So you can see that these are the 3 animal drugs, animal drugs that have been approved, are being used to treat human diseases. GMO goats, GMO rabbits, and GMO chickens have been used to produce drugs. Now, these things people appreciate because they save lives, right? It is when healthy people have to use GMO products, that's when there is a public uproar, right? Is the concern warranted? Okay, so I would like to give a few examples of GMOs. So this one particular GMO is GMO potato, approved by the USDA in 2016 in the US, right? So you can see that these potatoes, they have a specific disease that affect potatoes. These are called late blight disease, right? That late blight disease can devastate all the crops. And in fact, that causes the famous Irish famine in the 1900s because all the potatoes got infected with that and they didn't have any harvest and lots of people died, right? So that can devastate the industry. What happened, it was that in order to make the potatoes resistant to this late blight disease, a gene from a wild relative of potato, so no new gene is created, right? This is a gene from a relative of potatoes that was taken out and then it was inserted into the russet and Atlantic varieties of potatoes. Now these potatoes will be resistant to this late blight disease. They will never be like that. So you can see that this field grows both conventional, non-GMO potatoes and GMO potatoes. These GMO potatoes are healthy when there's a late blight disease coming. However, the non-GMO potatoes are devastated, right? In the old days, before this GMO technology, all farmers can do is spray a ton of pesticides, hoping to save the crops, right? You can see how much damage this can be for the environment, all the pesticides being sprayed, right? And for the farmers, they have to be exposed to high levels and concentrated pesticides. And we, as consumers, have the residues of pesticides, right? So definitely this GMO potato is a saver for the industry and also it's good for our health. And another unintended consequence of this GMO potato is that it actually reduces another carcinogen in potatoes. So we know that when we bake anything that has a lot of starch in there, including potatoes, there is a very small amount of carcinogen that's developed, right? Even you use organic potato, same thing happens. So in this GMO potato that's generated by this technology, the carcinogen, the small amount of carcinogen actually is reduced when you bake the potato. In fact, this reduces the carcinogenic property of potatoes by 2 different mechanisms, right? So there are people that give a blanket statement that says, oh, GMO causes cancer. That is totally not correct, right? You can see in this potato example alone, we identified 2 different mechanisms for reducing the carcinogenicity. The other use of GMO technology is to preserve our most important resource in the world, right? We know that water is extremely important, and fresh water, it takes a long time to regenerate. And when we think about using water, we think about taking a shower, we think about flushing the toilet, but that's peanuts compared to what we have to use for agriculture. You can see this diagram here, this domestic use, flushing toilets, and taking shower, that's a small percentage. Industrial use, I always used to think industrial use of water is a huge amount of water. Look, it's nothing compared to this green area that's used in agriculture, okay? Now, water is something that the world is having a shortage of, fresh water. And in fact, there are people that says water is the new oil, but I think the water is more important than oil, right? We as humans have lived in the world without oil for thousands of years, right? In life, we can just get rid of oil all of a sudden. Life will be inconvenient, but we're gonna be alive, right? How long can we live without water, without fresh water, right? So we're gonna have to think about that. Now, how much problem do we already have with fresh water? This is what we see in the US, right? Rivers, ponds, lakes get dried out. Agricultural land, if you don't water with this rotating mechanisms, it's dryness, right? So we are facing a huge water shortage problem in the US. And in Africa, it's much worse problem. It's devastating farmers in Africa, right? And it took Monsanto 12 years to develop a type of drought-tolerant corn. This is, again, by genetic engineering technology. You can see that in this field. Corn growing together under the same condition, conventional corn are much, much more retarded in their growth compared to their GMO peers. So from 2007 to 2015, there was a project to grow drought-tolerant maize in Africa. Africa used to be the continent that was completely resistant of GMO because they were extremely afraid of GMO. There was no choice. They had to adapt this new technology. And that gave them 20 to 30% increase in farmers' yield from this project alone. Okay, so I am not able to talk about every single GMO that's been developed. Every single one of them has a beautiful story behind them. I want to point out that in the US, every country approved their GMO varieties by their own regulations. In the US, there are 12 different types of crops that have been approved to be grown and to be marketed. You can see that their pictures are shown here. I will not go into details of single one of them. But I wanted to put emphasis on one particular type of GMO that is the widely used, I would say, crops in the US and in the world also. So this is called Bt. Now, what is Bt? Bt is a bacteria. It's called Bt, okay? Bacillus thuringiensis. So we short that as Bt. The Bt bacteria is unique that it has a gene called Bt. This gene makes a protein called Bt. Now, this protein Bt is unique in that it kills larvae, insect larvae. So insect, when it eats the Bt gene, it's gonna die, right? It has a leaky gut. So Bt has been widely used for years by organic farming. So what organic farmers do is they spread Bt, either the bacteria or the Bt protein on corn or crops as insecticides, okay? So you can see how inefficient that is, right? You spray today, tomorrow it rains, everything is washed off, you have to spray again, it's more expensive, and lots of labor, and just not very convenient, right? So biotechnologists said, well, we can take a page from the organic farming industry, right? Instead of spraying Bt, let's put Bt gene into the corn, so the corn would make Bt themselves. And when insect would come in and bite the corn, they bite a few bites of the husk and they'll die already. So they will never damage the corn. You can see that this is the result of Bt corn. No damages, no holes, no molds versus conventional corn, a lot of problems, right? Who would want to go to supermarkets and face all of these things, right? This is why in the supermarket, if you go to the produce section, unless you're buying organic corn, this is the corn that you're buying, Bt corn, right? Well, does that affect human beings? No, it does not. Why? Because we humans do not have the Bt receptor. We do not react to it. We can't react. We don't have the receptor. Insects do, okay? So what is the result of the Bt technology to our world, ourselves, our industry? So you can see that this x-axis is the year from 1996, that's the first year the Bt corn was introduced, and over the years, farmers really embraced the technology. Why? Because they don't have to spray insecticides, don't have to deal with the highly concentrated toxins, and they don't have to hire the actual labor to do all the spraying. And this is why farmers embraced the technology. By 2014, up to 80% of the corn in the US were all Bt corn. Farmers loved it, right? What happens? So we see farmers benefit from it. How does our environment benefit from it? This is the use of insecticides in the US. While the BT corn was grown in the country, the use of insecticides plummeted, right? So our environment is fundamentally, I would say, saved by BT corn. Our consumers are also saved by BT corn, right? If the farmers don't have to spray it, we don't get the residual either, right? So you can see how important BT technology, not just BT corn, there's also BT other crops, have an impact, a positive impact on consumers, environment, and farmers. And there is one more added benefit, which was also unintended, right? Is that corn, as we know, it can carry toxins, mycotoxins, because when insect bite the corn, it leaves a hole on the husk, and then that can increase the moisture in the corn because the rain would just get in from the hole, and then you end up with all these moldy areas from insect bites, right? So if the insect can't even penetrate the husk, none of these would happen, right? So you can see that these mycotoxins, if insect bite them and the corn develop these fungal infestation, they produce toxin. These toxins are highly toxic to farm animals and to humans, right? You can see that this is this study after 21 years of field data. They concluded that the BT corn reduces carcinogenicity, right? Different type of mycotoxins by at least 30% of reduction because BT corn was introduced. You can see how important that is, that not only do we use less insecticides, we also reduce mycotoxin production by the same technology. And in fact, I have to say, I prefer eating GT corn. If it's not conventional, if it's not GMO corn, I'm not interested, right? Farmers, there was a study in Florida, farmers spray every week 17 times of pesticides in the growing season of corn. But when they use BT corn, they only spray 3 times, once a month. You can see that it's a no-brainer. There's less toxin, there is health, good benefit for the environment, right? I absolutely choose GMO, and farmers embrace GMO. So, you know, farmers can't grow GMO. A lot of them turn organic. Why? Because they can't deal with the spraying and mixing of toxic chemicals anymore, week after week. This is actually one of the reasons many Indian farmers become so much happier, because their family gets healthier. They don't have to deal with this high levels of toxins anymore. And I would not have time to talk about all the other benefits that plant GMO bring to us. You can see that I gave a good example on insecticide resistance, drought tolerance. There's herbicide tolerance I haven't had a chance to talk about. Disease resistance in papaya, enhanced nutrition value, reduced food waste, improved manufacturing processes, nitrogen fixation, reducing fertilizer use. None of those I have time to talk about, but all of those things can be brought about by plant GMO. Unfortunately, scientists are very busy in developing these technologies, but they did not have time to, they left the public behind. So the public really have very bad perception of GMO. Mainly they're concerned if there is a lot of misinformation out there that suspect that talks about GMO causes cancer and many other diseases. There are others, so let's take a look at that. You know, you probably have heard GMO causes Alzheimer, infertility, allergy, all kinds of things. That just cannot be true. If you think about these diseases, each one of them is different. They all have very different mechanisms of development, right? How can GMO causes all of that? This is just, you know, just from the face value, this can't be true. There are also other people who say, oh, you know, my friend, she got cancer because she didn't eat organic food, she ate GMO. Well, there's also so-and-so that only ate organic food and still got cancer, right? Does that mean anything? This does not, because all of these talks are not scientific, they're anecdotal. If you want to prove something that causes Alzheimer or causes cancer, you're gonna do double-blind, randomized, controlled trial, right, with sufficient number of subjects. So that's how you conclude instead of doing this, oh, my friend got sick because they ate GMO. But there are still a lot of people in the society that are extremely concerned about GMO safety. They say, oh, why are cancer rates so high, right? So we should take a look, closer look at GMO. So let's take a look. So you can see that this is a year again. The x-axis is a year again. The y-axis is the percentage of the planted area. So you can see that since 1996, the BT and the HT herbicide-resistant crops were introduced in the US. Farmers embrace the technology, right? By 2017, about 90% of soybean, cotton, and beet and corn, 75 to 90% are all GMOs, right? So if these GMO causes cancer, we would see skyrocketing cancer incidence, right? Cancer would just pop out everywhere in our society. What is the data during this period? This is year again from 1999, about the time that GMO was introduced, to 2013. This is a cancer rate in males in the US of different race and ethnicities. You can see that among males, cancer rates actually dropped, right? Because they quit smoking. And this is the cancer incidence in women in the same period. Cancer rates stayed about the same. There's no skyrocketing of cancer rate, right? So definitely there is no correlation between eating GMO and cancer. So in 2016, the National Academy of the Sciences, the cream of crop of all scientists, did a comprehensive review of all the literatures, right? So what we just talked about, cancer rate and GMO adaptation, that's correlation, right? There are also direct randomized controlled double-blind studies, and these studies were summarized by the National Academy of Sciences, and they state that there is no substantiated evidence of any risk of GMO to humans. And there's no cause and effect evidence that the GMO harms the environment. In fact, there's favorable economical outcome to producers, okay? So this is after studying all the data, scientific data in the field that were published. So basically, to summarize that, there is absolutely no evidence that GMO causes public health problems. There are other people who have trouble with corporate greed, okay? So let's take a look at that. They blame Monsanto. They blame Monsanto for producing evil seeds, right? This is corporate greed. So let's look. This is the year of GMO introduction and adaptation. And this is how many acres that are grown in the world. Now, this is not in the US. In the world, you can see that this is a tremendous increase of GMO that is being grown in the world. Now, are these farmers growing GMO because Monsanto forced them to grow GMO? It is the same question as, can Apple force us to buy iPhones? Apple iPhones have the similar big increase in sales, right? Why do we spend more money to buy iPhones? Because it's a good product, right? We would rather spend the money to buy a good product. It's the same reason why farmers would rather spend a little bit more money to buy the GMO seeds, because it brings them a lot of benefits, right? You know, we understand that Apple have to charge us more because they have to spend a lot of money to develop all the programs that we enjoy. So do these biotech companies. They spend a lot of money to develop these specialized seeds to create extra benefits to everybody. So they have to be compensated. So they have money to continue their development. But why do we have such wrong perception about GMO and the biotech industry? Well, there are a lot of people that have good intention, yet I would call them, they're the plumbers, they're the cardiologists that are trying to fix a dental problem, okay? They have some superficial knowledge about the field, yet they make these sensational things like award-winning documentaries, accusing the technology of killing Indian farmers, toxic tears, GMO OMG. All of these things create a ton of fear to the society. Even people that are winning the award. That does not mean that these are people that are experts, that they are qualified to comment on the technology, to educate people on this particular technology. Okay, so I wanted to give one example about how they're wrong on the Indian farmers killing themselves because of GMO. Now, the Indian government is very afraid of GMO, right? They do not want GMO. They want nothing to do with the GMO. However, they have to, in 2002, they have to introduce GMO cotton in their country because they have these bollworms that just devastate the cotton industry. So from 2002, they introduced this to the country. You can see how much farmers embraced it. They just totally loved it. They grew a ton of it, skyrocketed adaptation of a GMO technology. This purple curve describes over the years as farmers adopting the GMO technology, the farmer suicide rate, okay? If we believe Monsanto is using the seeds to kill farmers, the farmers, as they grow GMO, they should kill themselves more, right? No, they did not. So clearly, Indian farmers did not kill themselves because of GMO. They just committed suicide at the same level before and after GMO introduction, right? In fact, the Indian government is very smart. They have this law protecting farmers. You can buy GMO cotton seeds from Monsanto, save the seeds, replant them. In fact, you can sell them without rebranding. You can say, this is GMO cotton seeds, yet I can sell it. You don't have to buy from Monsanto, you buy from me. This is the Indian law. There's no need for farmers to kill themselves. You can see how wrong those documentaries are, right? So last I want to close is that many people are very fearful of the GMO technology as if it's a hideous beast, right? However, we see in this photo, this gentleman is hugging a tiger in the middle of nowhere in the winter where there's no food, right? How come he can hug the tiger? He knows the tiger, right? So if you know the technology, you'll be able to embrace that. So I'm gonna stop here, thank you. Stop sharing.
Now we're going to take a look at why public policy matters in science. Policy is usually a result of trying to enhance geopolitical, social, financial positions, or issues. Often people's moral stance adds an emotional context to the discussion. My role in monitoring agricultural issues for our college and our state legislature really leads me to be able to hear what legislators think and what they want to know. One day when I was down at the Capitol, I was visiting with a legislator about things that we needed to do to improve the economic stability of farmers, including why science was important. And his comment to me was, my constituents' feelings will always have more weight than your science. They vote in my district and you don't. And that's hard truth is what really helped me to decide to engage in this process. Getting voters to speak about science is extremely valuable. This dovetails with why we need to get as many farmers, families, 4-H'ers, agri-science FFA students, and extension volunteers involved. That's to say nothing of those that work for colleges and universities who are comfortable talking about why science matters in their personal life and at home. We need moms talking to neighbors. We need the medical community who relies every day on science to share the opportunities that we have in GMO. We need community nutritionists and dietitians letting their clients know that food shaming because they don't buy organic is uncalled for. These socio-political conversations are damaging public confidence in science, partly because of the tactics employed by their advocates. If left unchecked, this is going to have consequences that deny people basic needs and opportunity for better lives. When we look at public policy, it's really a set of principles. It's also an agenda. It's officially designated intentions that we have through laws, through regulations and orders. Most of all, it's knowledge and advocacy that drives the outcomes. And dialogue and the things that we did in our project are things that help to do that. Can I have the next slide, please? So what are the things that we look at in terms of what we have for creating policy? There are those that look at developing policy as something that just high-paid lobbyists do. And that means it's a dirty process and it lacks transparency. We see it all the time. Anytime you turn on the news, there it is. Something's happening that's created policy that is very, very controversial, it's very crisis-oriented. And one of the things that we see is that often there's a lot of disparaging rhetoric that happens, one side versus another. And the other side always looks for a way to create questions and add confusion into the discussion. The goal is to introduce alternative information into the debate and muddy what should be the ability to have a real rational conversation. What is hard to diminish is when citizens start lobbying for certain topics. That's pretty hard for an elected official to accuse them of being corporate, of being driven by greed, all the things that Cindy talked about earlier. But instrumental is what we do to build coalitions. It's how we find out who else thinks like us. So when we create public policy, one of the things that we look at is who else has the same position that we do? What are the desired outcomes? Are there similar goals? Can we create a common vision with another group of people or another organization? You know, relationships are all about how we can work together. And in those clusters of people that we pull together, some may have some opposing viewpoints. What we really need to do is make sure that we stay the course on a defined goal, and then let the other things go to the side for another day. We have to find out if there's agreement on the status of the issue. We need to insist on innovative, flexible thinking. And then we have to develop proposals, or one proposal, whatever your group comes up with, and identify the ideas that have value. And who are those ideas do they have value for? Groupthink is really important to us in terms of how we see which ideas keep raising to the top. And if we can't find commonality, then that's the point where we all agree to set aside. We'll talk more about that later when we look at dialoguing. Now, if we could look at GMOs and public policy. One of the things that we identify when we start visiting with where and how do GMOs intersect with policy, we talk about social science and what its nexus is with agricultural science. GMO is the poster child for this issue. Social science, sometimes versus agricultural science. I want to share an example of how messaging can really derail a meaningful conversation around public policy. A few years ago, our college was asked to present at our state legislature on GMO. We get asked to come down and provide expert opinion. We were very transparent in terms of who we were working with on scientific trials. We showed that we took no money from corporate with regards to any of the GMO work that we do. Yet we were still rebuked because we accepted grants from USDA. And I was kind of taken aback by that. And when I delved into it further, the people on the other side said USDA has been populated by people who work for Monsanto and people who work for corporate America, and that they were not there to help people like organic growers. And so even though it was federal money that we do have a lot of research dollars with, just like your universities, it was still looked upon as negative. As science-oriented colleges, we need to be able to share our findings in a way that focuses on the credibility of science. When the conversation turns to science, the major point of view really needs to have a ability to point to our research findings. And we need to be able to independently verify. And that's why we rely on peer-reviewed science. When you ask people about peer-reviewed science, they really don't understand what that means. We have to use messaging to help them understand that that's where we get quality science. Many studies have been influenced by agendas, and they're not peer-reviewed. Methodologies are called into question, interpretations are redirected to a point in the wrong direction, and marketing via social media has become key to clouding peer review and why it's so important to identify in quality science. We need to be able to message on what quality science brings to society. Moreover, the allegations regarding the credibility of scientists are often used to damage what can be very, very promising careers and a lot of hard work that's been done by people who have looked into how we need to proceed with science in our society. The funding of GMOs and anti-GMOs should be questioned. It's almost a given that people will blame Monsanto for GMO, even today when the company no longer exists under that name. There is little mainstream media who are willing to question anti-GMO or the conflicts of interest around those actions. Once you dive into the funding of both sides, not one, not the other, but both sides, you will see, in fact, a lot of money follows the agenda. One of the terms that we talk about is parallel science. Parallel science involves concepts that serve political goals. and those who use it often link terms to the word science. Words like concerned, responsible, are all things that we have to take a look at in terms of how we are moving forward. The real issue that we have to get to is what needs to happen, how can it happen, and what are the ways that we're going to be able to move forward in a manner that brings everybody to the table. Everybody needs to be able to be heard. And again, we're going to get to that when we talk about the importance of dialoguing. I was at a public hearing one time at the state legislature, and there was a controversial food bill that was a food safety bill. And the Department of Ag had their public health veterinarian come in. He's a trained microbiologist and a turned in addition to being a veterinarian. And he spoke about the science behind why food safety was so important. This was met with a lot of resistance by folks on the organic side. A person came up to give testimony, and he introduced himself as a PhD and proceeded to give a very different perspective than that public health trained veterinarian. When it was time to be questioned, one of the legislators asked him, "What's your PhD in?" And they found out that it was in sociology, not food science, not animal science, not microbiology. The legislator pressed him further and asked if he ever even had a class in food microbiology. And he shared no, that he had never had a class, he'd never taught a class, but he has done a lot of research. The legislator asked, "Where did you get your research?" He said, "Well, you can get your research anywhere." And the legislator responded, "Google science is not what we want to hear here in the legislature." So those are some things that really just get us thinking about why do we need to go ahead and dialogue. One of the pieces that we talked about is where does GMO crop up in policy, pun intended. The White House during the Reagan years in 1986 realized that they needed to come forward with a coordinated framework in terms of how they looked at biotechnology. It determined that regulations focus on the final food product rather than the process. Very different than our European friends who look at the process versus the final product. Plant GMOs were determined that they needed to be regulated by the Department of Agriculture with APHIS. Food, drug, and biological GMOs are regulated by the Food and Drug Administration. And pesticides and microorganisms that GMOs are associated with are regulated by the Environmental Protection Agency. These are all things that again, pause and give us a lot of thought in terms of why things are separated, why things look differently, and who is doing the oversight of all of these issues. The other thing that we want to get to is the policy around GMO labeling. You know, Cindy talked about the fact that we have standards now. In Congress, we had the National Biological Food Disclosure Standard in 2016. That required the United States Department of Agriculture to create labeling standards for GM food. And one of the real key pieces that came out was that bioengineered food shall not be treated any different, no safer, not as safe as their non-engineered, bioengineered counterparts. The law required labeling only on bioengineered foods intended for human consumption. And one of the things that they don't have to be labeled on, a number of things, are foods derived from animals, such as eggs, meat, and milk. Refined ingredients, food served in restaurants, and food manufactured and sold by small manufacturers. If we look at the next slide, we can see that here's what the GMO labels look like. And you can see that there's very little that you can do to really pull this apart and really talk about a lot of other things that happen around labeling. One of the pieces that has been pointed out numerous times is you can simply label your product GMO if that's, I'm sorry, you can label it as organic if you in fact even think that your product might have a GMO process involved. The text on the food packaging, again, partially produced with genetic engineering. You can have the symbol. There's also electronic and digital links that can be scanned in. These are all things that we know that consumers have asked for. They've been very clear. While they don't trust it, they do want to know that there's some form of recourse that they have to see whether or not it's actually being identified. So what are some of the quick GMO talking points? You can certainly see that there's plenty of talking points for GMO. You can open up any pro-GMO site, Google it, look it up in your own university. There's plenty of places where you can see where there is proven science around GMO and what it takes to to share this information with society. Some of the key things that we would look at is that we have improved human health. We have improved plant health. We have improved soil health. And these are just a few of the talking points that we can share. What's imperative is that those speaking to GMO benefits personalize and tell what it means to them. For instance, we opened our program talking about diabetes. I have several members of my family who are diabetic. Make it personal. My family comes from a dairy farm. I was born and raised on a small dairy farm, and we've always been very progressive. One of the things that we have no problem doing is feeding our dairy cattle beet pulp and other grains to our cows. I have no desire to spend more money on organic grain when I can have a perfectly safe product that's made with GMO. These are the kinds of personal stories that I tell my legislators and that I encourage our farmers to share when they talk to their legislators. Most of the feed that we have is GMO based, and that's not only safe, but it's very cost effective. When you make it personal, that legislator that you vote for needs to hear what you have to say. There's plenty of resources that we've identified for you to see here. Please feel free to swing back in with us if you've got more. We'd love to hear what ones you like to use. But it's really important that what you do is always backed up by peer-reviewed science. That's part of the message. That's part of what we need to do as communicators, is make sure that we all can share and show that this is a personal issue for us. It's not just a scientific one being paid for by corporate America. Stacy, over to you.
Actually, Bonnie, we're going to bounce right to you because we're starting our section on communicating about GMOs, and you can lead us off with dialogue.
Great, thanks so much, Stacy. So we talked about what is dialogue. At our university, we had the opportunity to participate in a program on dialoguing. What was identified as the real need to get to what does it look like in terms of having a positive conversation with somebody that you may normally not talk with. And it does matter. It's important because it's a respectful way to listen and interact without being accusatory. When we understand the need to hear what is being said and being able to ask questions without fear of being labeled, information can be synthesized so much differently. As an approach to teaching and learning, this is one of the things that we need to get to. We need to be able to ensure that people can have a face-to-face conversation or a group conversation. We need to be able to exchange ideas and values. We need to make sure that people feel safe in sharing what their point of view is. We need to learn how to actively listen to those different values, beliefs, and experiences. We need to be more empathetic with each other. There's not going to be any winners or losers, but we share with others and we recognize our differences. You have to acknowledge those differences, yet you have to creatively come to a place where solutions are going to come forward. And it's that real practical world situation that brings GMOs into the conversation regarding dialogue. So why are we dialoguing? We choose to dialogue because we want to be vested in doing what we can to improve on something. For our group, it was a discussion to improve on how do we discuss how GMOs are important to all of us. For those who are participating in the GMO dialogue, we needed to be vested in explaining how scientific application can improve life in a variety of ways. And for many people, that's a challenge. Science is something that we sometimes are raised to be a little afraid of, especially as we're coming through school. And it's not until we get into college, we get into professional careers and lives, that we understand that science is a very, very different thing that we can bring forward and rely on. So what we do is we use science in a decision-making process, but we also incorporate the human elements and dimensions in that. It helps us figure out how we need to address the denial of what's in science and why it's good. We address the perceived risk to biodiversity, as well as human, animal, and plant health. We talk about the role of technology in our lives. When we talk with folks in our dialoguing projects, many of them don't come from the same place that we do. And we need to help them understand that technology is very acceptable. And when it's rejected, that's also a challenge as well. We need to help delineate what we reason and internally deliberate. One of the things we have to do is understand that other people are doing the same thing we are, but they're coming from a very different point of view. We have to address the rational. We have to address and be rational and seek to alleviate suspicion about those who think differently. And that's very, very key to what we do. We have to agree that we're all coming from our place where we have our foundation in thinking about something and making it so that it's a much more opportunistic place to have open dialogue and to be square and be upfront with each other. That's where we're going to start to be able to put some of the problems and challenges we have with science to rest. How about debunking myths, Stacy?
All right, Cindy, I'm going to stop sharing so that you can start again.
Stop recording, Stacy. Okay, so next I would like to share a few things about myth debunking about GMO. And I wanted to share this document first. Cornell University has assembled this very beautiful short document about 10 myths of GMO. They go through every single one of them using very lay terms. So I would highly recommend this particular very easy read for your own knowledge. And what I would like to do is I would like to go through a few slides, share a few slides with you about GMO myth. So first of all is that there are people who said GMOs are not thoroughly studied. Now, this is totally untrue. We know that there are more than 1,000 studies. These scientists from Italy, they did a meta-study. A meta-study is study of all the other studies that have been published. So what they did was they found 1,783 studies that were published from just 10 years period, from 2002 to 2012. This is only half of the GMO introduction since 1996, right? So you can see that there's a lot of studies already, and that their conclusion is that the scientific research conducted so far has not detected any significant hazard directly connected with the use of genetically engineered crops. So all the studies that they have done showed that there is no problems of using GMOs. And is this enough, right? Has any conventional food been studied like this? GMO food, in fact, is the most studied food among all the three categories: conventional, GMO, and organic. If you look for organic food studies, there are very few, maybe a few dozens, right? But the GMO, the publications, I am sure if people study the next 10 years, these numbers would have doubled, right? So GMO is not just studied, they are the most studied food. And also, among all the studies, there's another attack on GMO studies that says that, oh, you know, most of the studies are only done in the mouse, and they were only conducted for 90 days, which is true. That's the industry standards, right? And they say that there is no multi-generation study. That is also true. However, there are multi-generation data. You have look at mice, for example. Their food, the main ingredients are corn, soybean meal, right? These are GMO food. They've been eating that since 1996. Today is 2020. They've been eating GMO food for more than 140 generations, right? If GMO causes cancer, infertility, all the other problems, we would have absolutely no lab mouse to use, right? That's just totally untrue. And same thing for domestic animals. They eat a lot of GMO food with no problems. And our own experience, humans, right? We you know, just every single piece of corn, if you go to the supermarket, you buy it's GMO, you know, unless you buy organic. What is our own experience, right? Did anyone get sick from eating a piece of corn? Did anyone go to the hospital, emergency room, because they ate GMO? That is totally untrue, right? So we have this years of safety records of using GMO in animals and in humans, right? There are other people, we talked a little bit about big corporations, and there's other attacks on big corporations that says that they force farmers to save seeds. They drive small firms out of business. Is this true? That is not true either. For example, just let's use corn as example. Corn are hybrids, right? Farmers cannot save seeds. They don't save seeds anyway, because the corn, like we say, they were bred from different varieties to increase production. If you save them next year, you're not going to produce as much. So they never saved seeds in the first place, right? So this is really not a problem at all. That's basically created. Now, did the big corporations of seed companies consolidate into large firms. Yes, it did happen, right? Look, Monsanto, which is now bought by Bayer, and Bayer over here, and DuPont and Syngenta, they did consolidate the seed company in the world. This is definitely not incorrect. However, how is this different than the other vertical integrations in the food industry? We can see that these big companies, they own all the other brands, even though thousands of brands of food, as if we have a lot of diversity, they're actually owned by these few big corporations. It's not different, okay? In fact, even in the organic industry, they are going through the same consolidation. You can see that these organic industries are owned again by these big corporations. So there is really no difference. You cannot just say single out a biotech company for consolidation, right? And there's also other people who are concerned about GMO harming wildlife, right? Where does that come from? There was a lab-based study published in Nature in 19 years ago. This was produced in the lab only, okay? They studied these milkworms, milkweed leaves, because monarch butterfly, they land on these leaves, they feed on them, and that's how they reproduce. So these milkweeds, they usually grow on the sides of cornfield. So if corn are GMO BT, so their pollens can be blown onto these leaves, and the butterflies can eat it and potentially die, right? Because these are insects. So that study, when it was published, it immediately drew thousands of demonstrations trying to save the environment. I would unfortunately call these people useful idiots, because they did not truly understand the story. Because research scientists, including those people that published the initial study, they completed a largest field trial, and as well as a lab work. They studied the toxicity of BT pollens to these butterflies. And they found that these BT pollens do not carry enough BT toxin that is going to kill these butterflies. So really, this is a non-issue, right? Now, can other non-targeted species be affected? Probably. There are more studies being done. But again, if we don't grow BT corn, we have to use a lot of insecticides. Is that less harmful to butterflies than the BT corn? Definitely not, right? So I am going to stop here. I was going to talk about compare GMOs, conventional or organic. I don't have time, but I would be happy to share all the information if anybody wants to. So I'm going to stop here. Thank you.
All right, I'll start sharing again, just a second. And here we go. So now we're going to talk about our audience personas. Thank you, Cindy and Bonnie, for that background information. So we made our audience personas based on the survey results that we've collected and other information that's available, similar information to what all of you have. We have 4 audiences or personas up on the screen right now: Disbelieving Dan, Conscientious Kathy, Worried Wanda, and Masterful Michael. And these could be swapped out easily. Conscientious Kathy could also become Conscientious Carlos. But let's look a little bit at these 4 personas, and then we'll talk about some different messages that we have used in our team that you could also adopt similar tactics with, based on the dialogue processes and the science and debunking myths that our team has used. So we start with Conscientious Kathy, and in this audience persona, we see people that are trying to do the right thing. They're trying to make the right decision. They see a lot of conflicting information, whether it's out there from their friends on social media. And so for this audience, whether it's Conscientious Carlos, Conscientious Kathy, we're trying to give them information, science-based information, so that they can understand what GMOs are, what all of these different messages are, and make their own decision. One of the key points that our team has adopted in this whole process is that we're presenting science-based information so people can make their own decisions. We're not trying to sway our audience to one decision or the other. Rather, we're trying to help them create an opinion based off science and facts. So Disbelieving Dan is another audience persona that we developed. And again, this could be Disbelieving Desiree. You look at this as you want. We have a lot of different personas, but Disbelieving Dan is a little bit more skeptical about GMOs than our conscientious persona that we saw in the previous slide. This one also needs the science-based information and the facts, but you need to address these personas with those shared values. You need to make it personal and bring in your personal viewpoints with any of these. Disbelieving Dan, again, if you just go at him with your facts and you don't start with shared values, and Cindy will touch on shared values again in a little bit, you're never going to win an argument with him. You're never even going to be able to start a dialogue with him. So that's why we want to message to these audiences in an appropriate way. Masterful Michael, again, is one of these audiences. So when we first started this process with our team, one of the things we talked about was that you're not going to change everyone's mind. And there's some audiences that are so set in their viewpoint that it's probably a better choice to concentrate on personas or audience members that you can influence. Masterful Michael is on that line of whether we should be talking to him and trying to have a dialogue about GMOs or not. One reason that we choose to include the audience persona Masterful Michael is because this is an audience member who's sharing a lot of information, and because he's sharing information, or Masterful Martha, whichever way you want to look at it, male or female, but because this audience persona is sharing that information and they are seen as kind of an influencer among their group, that's why we try and dialogue and communicate and share messages with this audience persona, so that that ripple effect of the other people that they're reaching, we want to reach those people too, and we want them to be sharing that science-based information. Finally, our fourth persona for today is Worried Wanda. And Worried Wanda is trying to do the right thing, but at the end of the day, she doesn't have a lot of time to do all of that research on her own. So what our team, what we as communicators are trying to do for someone like Worried Wanda or Worried Walter, it's in this persona, what we're trying to do is give them that science-based information. Universities have a lot of credibility. We want to build off of that, and as our land grant communicators, as agricultural communicators, provide them with a safe source where they can find unbiased information that they can use to make their own opinions. So the message, we're going to just run through a couple message ideas that our team has used. Based on our survey data, we started with getting the story straight. There was a lot of confusion about which crops have GMOs. So you can see on this screen, this is off of our fact card. These are the crops that had GMO varieties. And once we started establishing which crops could have GMOs, the communication message gets a little more nuanced beyond that, because although there is an apple variety, the Arctic apple, that has a GMO version, there are thousands of apple varieties. So not only do we need our audience members to know that there is an apple variety for GMOs, or GMO apple variety, they also need to know that there's only one. And so every apple they see in the grocery store is not necessarily an apple. One of the reasons we started this was because when we did our survey, we had people write in a GMO crop, and some of the answers we got pretty interesting. You might have seen on Conscientious Kathy, she believes that oranges have a GMO variety. And then you'll also see Bonnie and Cindy talked about the labeling, that we have cat litter and salt that are labeled as non-GMO. So just trying to debunk that myth again and help people get the right information. The next message that we really focused on, because there was so much confusion in our survey data, was organic versus GMO. A lot of our respondents thought that they were one and the same thing. So we have dedicated a section of our website, and we also have on our fact card, trying to help people understand what organic is, how GMO is related to organic. So fake news. Cindy and Bonnie have both touched on fake news a little bit, and it's prevalent in our society. And as communicators, we are faced with it every day. And that's really one of the reasons that we have started doing these message campaigns and communicating about GMOs. This meme from Michael Scott, The Office, you all probably recognize him now, but this meme, it really exemplifies one of the reasons why we're trying to get this science-based information out there, because there's so much misinformation. So we all know from a land-grant university academic communication standpoint that you really need to check the credibility of your sources. There's the 4 steps of checking previous work, going upstream to the source, reading laterally, and circling back. But if you go back to one of our audience personas, particularly Worried Wanda, Worried Walter, that persona does not have the kind of time and necessarily the energy to really go through this 4-part process. So that's where we can build off the credibility and trust that our universities have, that scientists have, that farmers have. And that's one of the reasons we're training our farmer audiences to also communicate about GMOs with their consumers, is we can build off of that credibility of our sources, and so that our audience personas know that the information they're getting from UConn about the science of GMOs, the information they're getting from their farmer's market, from the farmer they're talking to, is science-based and reliable information. And so our message idea 3 is that the credible sources, we will help them with that, find those credible information. Message idea 4 is that we are sharing positive GMO stories. Our team worked with a digital media and design master's student, and we made a couple of short animations. This is the American chestnut tree animation about the chestnut tree being saved. We also have an animation about insulin. Previously, Bonnie talked about sharing those positive GMO stories. We really encourage the farmers that we work with to also share their positive stories, because that's one of the reasons we can, or one of the ways we can help change the conversation about GMOs, is to share that positive information and to get that out there. And this video has an incredible amount of traction on the UConn Extension YouTube channel, and most of that is organic and through searches. So it is proof that this messaging tactic is working for us. So message idea 5 is to admit what you don't know. And this is also on our fact card and our website. We also have another section on the future of GMOs. These are written by experts. So this one that you see up here, "Do GMOs Harm Health?" was written by our food safety extension educator. And then another one of our educators, our professors, wrote "The Future of GMOs." We admit what we don't know, because that's how we build that trust and credibility. And we also need to show both sides of the GMO issue. So Cindy, I'm going to let you talk a little bit about shared values in the couple minutes we have left.
Yes, I think Stacy gave a very good background about all the different people in the society. Because of their different experiences, they would have very different views of, you know, just things that we think should be very simple. You can be challenged, right? So when we go into a room and we're going to talk to a group of people, we cannot just start with from our own views, because then we may make the, you know, some people in the room feel they are invalidated in their values, right? So what we really should do is start with a shared value, common values. So we can start by asking a few questions, right? For example, a few that I listed here: who doesn't want to be healthy, right? That's very easy to answer, right? Who doesn't want to provide the safest and healthiest food for themselves and for their families, right? That is very easy for their children, right? And you know, who to go in a little bit further, who doesn't want to provide true information to their family and friends, right? You know, family, friends count on us to give them good advice, right? You know, we wanted to give them right information, right? We don't want them to lose faith in us because we pass something that's not correct, right? Because, you know, people may basically think that you don't have good judgment, right? So can you have the next slide, please? To just go down a little more on this, you know, how do we talk about look bigger into the shared value scheme is, you know, there are people who say, you know, GMO, I don't really know much about it, I'll just stay away from it. We got to think about what is the consequence of our choice, right? what is the consequence? Do we care about the environment? I think that's an easy answer because more and more people are realizing that we're having this big problems, you know, on the planet. So what we choose have to do with how we're gonna live in the next 50 or for the future generations. And do we want to spray all these insecticides? Do we want to make all these insecticides and pesticides, right? And do we care about our fellow citizens, farmers? Do we want them to be subjected to all of these dangerous pesticides? So all of these things are shared values that we wanted people to consider. So I'm gonna just stop right here.
All right, Bonnie, you're gonna avoid the argument?
Well, I sure am, Stacy. One of the things that we look at when we're avoiding an argument is, let me just ask people who are watching this session today, how many of you are a type A personality? How many of you are trained to speak up, speak loud, speak often? Do you realize there's a better place? You know, do you ever give on where and how somebody else's idea is really brought forward? So there's a lot of things that we can do to avoid an argument. Those are listed here. But one of the big things that we need to be able to acknowledge is that we need to remain calm. We need to check our ego at the door. We need to be able to listen and be receptive. We have to be super patient. We have to understand that other people deserve and need to let their thoughts be known. And then we have to recognize if things are becoming judgmental. We have to be flexible, and we just have to keep asking about more clarifying questions.
So if it does become argumentative, which we hope it doesn't, we encourage you to diffuse the situation with the 7 steps for difficult conversations: listen, ask, summarize, validate, express, negotiate, and commit. As trained communicators, we are confident in your ability to handle all 7 of these steps. And you've probably seen these powerful questions to use in a difficult conversation. What do you think? What leads you to think what you think? What would you like to accomplish? What is the most important thing to you? And what do you suggest we do? So we are basically out of time for this session. We appreciate you joining the Association for Communication Excellence at our virtual conference this year. And we'd like to encourage you, we've just touched on the topic today of communicating about GMOs and creating consistent messages. Bonnie, Cindy, and I, as well as one of our colleagues from the University of Connecticut, law professor Robert Bird, are creating an online certificate about GMOs. So we invite you to visit us at gmo.uconn.edu to learn more about our online certificate. It's going to launch in January 2021, and we hope to see you there. We will, of course, be sharing that information with ACE as well. Thank you all for joining us today.